All right. Good morning, good afternoon, ladies and gentlemen. Welcome to this series of online lessons. If you haven't already, subscribe to the channel and leave a like for this lesson. All right. Now, this lesson is a request from Jafet Mubanga. Shout out to Jafet. This is a tutorial sheet from Northern Technical College, and basically the questions I am going to answer is just question number 7 and 8, and we'll see how we'll build on from there. All right, so here we go. So the diagram shows a trapezium A, B, C, D, in which point A has those coordinates, point B has those coordinates, point D has those coordinates, and you've been told that this is 90 degrees, so meaning that this is also 90 degrees since these are parallel. Okay, so these are parallel, meaning that this is also 90 degrees, and AB and DC are parallel. Okay, now for parallel lines, if there is a line that is okay, so if we have this line and there is another line there that is at 90-degree angle with this line, what you should know is that the inverse or the gradient of this one is actually the inverse of this gradient here. Okay, it's actually the negative inverse of the other gradient, so which also applies to say the negative inverse of this gradient is the negative inverse of that gradient. Okay, so that is just something that you should know. Okay, having that said, let's look at the question. Question 1 asks us to find the coordinates of C. Okay, so C is right here and we're asked to find the coordinates of C. Now this is very simple. It can be done in two ways. So the first way is considering that if we have this line or the equation of this line and this line, when we extend the equation, we can actually solve these two lines simultaneously to get the coordinates of the point where they meet, which is this point here. Okay, so which is what we'll exactly do. So we'll just find the equation of this line, which should be in the form y is equals to mx plus c, and we'll also find the equation of this other line. Okay, this other line, which will also be in the form y is equals to mx plus c. Okay, after we do that, we are going to solve these equations simultaneously and we'll get the coordinates of that point. Now, to find the equation of a line, you need to know the gradient. Okay, so we have a point there and the point there. So we have a point for this one. We just need to know the gradient of that one and we'll be able to solve the equation of the line. Same applies here. This line, since this line is parallel to this one, meaning that they have the same gradient. Okay, so that's to say the line, this line and this line, they have the same gradient. So if we find the gradient of this line, we have found the gradient of this line. So let's find the gradient of this line. So we have 2 points there, so it's easy. So the gradient is equal to the change in y. So m is equals to y1 minus y2 over x1 minus x2. So we can name any of these points to be our x1 and x2 and y1 and y2. So this is x1, y1, then x2, y2, and we replace in the formula. So our gradient will be equals to y1, that is 6, minus y2, that is 0, divided by x1, which is 4, minus x2, which is 2. Okay, so make sure that the ones are in the same row, like here y1, x1, and the twos are in the same row here. So it doesn't matter if you start with y2, it means that the y2 here, meaning that down here they should be x2, so they should be in the same row there. So simplifying this, we are going to have the gradient of this line as 6 minus 0 divided by 2, which is just 3. Okay, so the gradient here is 3, meaning that the gradient here is also 3. Now having the gradient, okay, having the gradient and a point, we can find the equation of this line. So basically you just insert x and y for you to find c. So this is your x and that is your y. So you have you are inserting in this formula. So your y is 2 is equals to your m is 3 times your x is 6 plus c. What you're interested in is the c. So this will be 2 minus 18, which is c will give us negative 16, is it? Okay, so this will give us negative 16. So when 3 times 6, that is 18. When we transpose it here, it will be 2 minus 18. 2 minus 18 will give us negative 16. So meaning that we have our c and we have our m, meaning that this equation, or the equation of this line, is basically y is equal to, our m is 3, so it will be 3x plus, or c, which is 16, so it will be minus 16. So 3x minus 16. So this will be our equation for this line. Okay, now we need the equation of this line. Okay, now for us to get the equation of this line, what we should know is that when lines are perpendicular, like in this case they are at 90 degrees with each other, then multiplying their gradient, this should give us -1. Okay, they are inverse gradients, they are negative inverse gradients of themselves. So multiplying the gradient of this one and this one should give us -1. So we'll use this formula. So that is gradient 1 times gradient 2. This one will be gradient 1. So it will be 3 times gradient 2, which is m2. This should be equals to -1, meaning that m2, gradient 2, is equals to -1 over 3. So meaning that the gradient of this line, m here, is equal to -1 over 3. Okay, then now we need to find the equation of this line. So we do the same thing. We use this equation to replace. So our y is 6. So we say 6 is equal to our m there. Our m is -1 over 3. So -1 over 3. And our x there is 4. And this will equal to, this is plus c. Then we simplify this. This will be 6 plus 4 over 3 is equals to c. Okay, so this times this, it will be -4 over 3. And when we transpose it, it will be +4 over 3. So adding this will be 18 plus 4, which is 22 over 3. So that is our c. So basically here we just say 3 times 16, or we find the common denominator here. So we say over 1, the common denominator will be 3, then 1 into this plus this. This will simplify to c being equal to this. And now we can form our equation here. Our equation will be y is equal to m. Our m is -1 over 3 x plus c here, which is 22 plus 22 over 3. Okay, and we have our two equations. So now here we just need to solve them simultaneously, and we'll get the points there. Okay, so we'll get the points there. So basically we're using this formula to find the equation. We need a point, which is 1 point, and a gradient. So the gradient we have, so we said if lines are parallel, then they have the same gradient. So we can simply replace 3 there. Then x we need to find for c. So to find c, we just use the coordinates y and x. We make subject, we find c, and we simply replace back. So the y and the x are the placeholders. Then these will be like this. So now we can simply multiply throughout by 3. So we have two equations here that we need to solve simultaneously. So we have the equation, we can transpose this. So we can say this is y minus 3x is equal to negative 16. That is this first equation. We transpose the negative 3, so it becomes this. Then for the second equation, first of all, we can multiply by 3 throughout. So this will be 3y is equals to negative x plus 22. Okay, so that is basically we multiply throughout by 3 here, 3 there, 3 there. So the 3 here and the 3 there will cancel. The 3 here and the 3 there will cancel and remain with this. So we can put it here in that order. So we transpose the x. This will be 3y. When we transpose the x, it will be positive. So it will be positive x is equal to 22. Okay, now we solve this simultaneously. So we can solve by elimination, or we can solve by whatever method that you want, matrix method or whatever. Okay, so let's do elimination. So elimination, we say 3 there, say negative there, then we'll start adding. Okay, I am assuming you already know how to solve using elimination or whichever method that you know. So this would be 3 times y minus this, so this will give us 0. 3 times negative 3, that will give us negative 9x. Then negative 1 times x, so that will be negative x. So when these are added, this will give us negative 10x. Then here 3, let me just erase this. Then here we'll say 3 times negative 16. So that will give us negative 48, negative 48. Then we'll say negative times this, so it will be negative 22. Negative 22, we add this would be 0, there are 6, so this will give us 70, negative 70. So this will be equal to negative 70. Okay, we divide, we say negative 10x is equals to negative 70. We divide by negative 10 by negative 10, meaning that our x is equals to 7. Then we can replace in one of these equations here to find our y, or the original equation here to find our y. So we have y is equal to 3x minus 16. Where there is x, we put in 7, so y will be equals to 3 times 7 minus 16. So what is 3 times 7? So that will be 21. So this will be 21 minus 16, meaning that our y is equals to 5. Meaning that the coordinates, so you know the coordinates should be in the form x comma y. So meaning that the x part is 7 and the y part is 5. So these will be the coordinates of D. So that is how you are supposed to approach this question. So basically, first of all, you just find the equation of these lines, the two lines. Then you solve the lines simultaneously, the equations of the lines simultaneously, and you're done. So here, what you need to note is that two lines that are parallel have the same gradient. So you can find the gradient since you have this point here and this point. You can find the gradient of this one. Then it will give you the gradient of this one. Then after you find the gradient of this one, which is the gradient of this one, you also need to find the gradient of this other line by using the formula here. So this formula, as long as 2 points are parallel or they are making a 90-degree angle with each other, then their gradient multiplied will give us -1. So here we found this gradient here. Yeah, then from there we just find the equation of this line and this line, then we solve them simultaneously as we did here. And you can use whichever method you would want to use and it will give you the same answer, right? Now let's look at question B. Okay, let me zoom in. You can rewind to copy that. Let me zoom in and clear my board. Okay, so now for question B, you're asked to find the area. Okay, you're asked to find the area. So first of all, we have this point here, which is 7,5. So to find the area of a trapezium, it's very simple. We know the formula for area of a trapezium. Area is equal to half the long side plus the short side times the height. Okay, so the long side is this side, the short side is this side, and the height will just be this length from here to here. Okay, which I should note to you that it is the same as the length from there to there. Okay, so now if we have this length here, we have this length, so this will be the height, which is the same as that there. So what we just need is to find length 1. So we need to find the length in black here. So we need to find this length, which is length 1. We also need to find this other length here, which is length 2, and we need to find the height, and we can use this formula to find the area of the trapezium. So length, you know that finding length between 2 points, so we'll start with the length h there. So the length h there, the length between 2 points. So this, we've used this because it's the same as this. So the h there will just be the difference in x. So the difference in x, which is x1 minus x2 squared plus the difference in y, which is y1. So if you start with 1 here, you should also start with 1 here, y2, then squared. So in this case, the h, which I should use a red pen since we're using a red pen there. So h here will be equals to change in x. So if we say this will be our 1s and this will be our 2s, all the 1 coordinates will be here. So this is our x, this is our y, this is our x, and that is our y. So our x1 is 7 minus x2, which is 4. Then we'll square this, plus our y1, which is 5, minus our y2, which is 6. Then we square that. So we simplify this. This will give us 3 squared plus 1 squared. 3 squared is basically 9. So that is 9 plus that will give us 10. So that will be the root of 10. So this is the length of h. h is equals to 10, root of 10. Then now we need to find the black length here, so which we're calling a. A is the same formula that we're using. So we can say this will be our x, let's say this will be our x1, then this will be our x2, y1, y2. So this is x and that is y. So we use the same formula on top here. So x1 is 2 minus x2, which is 4. Then we square that, plus open brackets y1, which is 0, minus 6. We square that. Then here we just simplify. So this would be 2 squared. To be negative 2 squared. So this will never be negative inside here. So this will be negative 2, then squared, it will be positive 4. So it will be negative 2. Let me go step by step. Squared plus negative 6 squared. Then here, this will simplify to 4 plus 36, which will give us 40. So A is root of 40. Okay, so that is our A. Then now we just need to find B, which is this length from here to here. Okay, so we have the coordinates there. This will be our 1, and that will be our 2. It doesn't really matter which one you choose. So this is our X, this is our X, this is our Y, that is our X, that is our Y. So our B will be equal to the same formula here. So it will just be root of x1, which is 7, minus x2, which is 6. We square that, plus y1, which is 5, minus y2, which is 2. We square that, meaning that our B would be equal to root of 7 minus 6, that is 1 squared, plus 5 minus 2, that would be 3 squared. Okay, so now B would be equal to root of 4 of, what is this? So this is root of 10. B is root of 10 as well. Okay, so now we have our A. We have our A, which is here, our B, which is here, and our H, which is there. We can use the formula here to find the area. So basically, we're going to say area is equals to half. Our A is root of 40, so it's root of 40 plus our B, which is root of 10 times our height, which was also root of 10. So we simplify this by simply multiplying and adding. So I'll just say, so when we simplify everything here, it should give you about 15 units squared. So we don't know the units that are being used, so it will be 15 units squared. And basically that is how you are supposed to find the area of the trapezium. Okay, so that is it on that question. All right, so that is how you are supposed to work out that one. So area is the formula here. You just find the length. So you need the long length, the short length, and the height, which is what you've done. Now we move on to question number 8. Let me clear my board. All right, so let me just write out question 3 or draw it out. So the line y equals to 2x plus 3 intersects the y-axis at a point A. So this is the point A here. So why have I noted that as a point A? And how have I known that this will be slanting this way instead of slanting the other way? Well, first of all, if the gradient is positive, then this will be a positive line. It will be slanting this way. If the gradient is negative, then most likely the line will slant that way. Then in this line, we know that our x is equal to 0. So this is the line where x is equals to 0. So when you put x equals to 0 there, you know that it will be 3. So exactly this point here where the line is crossing the y-axis is at y equals to 3. So this point is 0, 3 right there. So the 0 is coming from the fact that this is 0. And when x is 0 in this line, y is 3. So we know that for this line, which is y is equals to 2x plus 3, this point A has those coordinates. Okay, so this point A has those coordinates. Then the point B and C are on the line. Okay, so there are other 2 points, B and C. And it happens that AB is equals to BC. So there is a point here somewhere. It's a midpoint there, such that AB, this line, is equals to some point BC. So B is the midpoint there. So just to put it out, so B is the midpoint, since there is another point C somewhere there. Okay, so AB is equals to BC. Then there is a line. The line through B is a perpendicular bisector. Okay, so this line through B is a perpendicular bisector, and it goes through the point -1,6. So obviously this could not be the points where B and C are. Maybe it could be down here because D is -1,6. So if I were to extend this line down here, if I were to extend line, okay, so B and C are actually down here instead of where I have written them, because the line that goes through point B passes through this point negative 1,6, so it would be somewhere down here. So just estimating, so AB, then C there, okay? And we are considering that these points are equidistant, so I'll just say AB here and C down there. So this is A, B, then C. Then a line that passes through B is a perpendicular bisector, so meaning that it is at 90 degrees. So meaning that you're being asked to use the same formula that we talked about, M1, M2 is equals to -1. So remember, whenever you have a perpendicular bisector, perpendicular meaning that the lines will be perpendicular. So that is what we have. And this line goes through a point, -6, which is this point, negative, it could be, yeah, somewhere here. So we're just assuming, so this is not accurate. So this is -1,6, somewhere up there. It could also be on top here, I don't know. It could also be on top, but it does not matter. So it could be the way I wrote it before. So let me just see if I can get back to how I wrote it before. So it was previously like this. This could also be the case, and where the line D here, so we're just estimating, so we don't know exactly. So where we have a perpendicular bisector through B like that, and we have a point D somewhere on top here, which is -1,6 on the Y. Okay, so this could be the right one. So now we have this, and now what we're just required is to find the equation of BD. So this equation of this red line here, BD. So what we need is the gradient of this line. Okay, so we know the gradient. So the gradient, we just get this. So this is in the form y is equals to mx plus c. So the gradient of this black line, m is equals to 2. Then to find the gradient of the perpendicular bisector there, we use the formula. We have a point there which is -1,6. So we use this same formula here to find c. Then we replace back. So first of all, we need to find the gradient of this other line here. So this is gradient 1 of this line. Then the gradient of this one will be m1 times m2 is equal to -1. So our m1 is this one. So it will be 2 times m2 is equals to -1. Then our m2 will be equals to -0.5. Okay, so we replace in this equation now to find our c. So meaning that our y, which is 6, here we replace 6, our m, which is this, and our x, which is -1, should give us what c is. Okay, so even here we're using y is equals to mx plus c. Okay, so our y is in this case 6. So we say 6 is equals to m, which is -1/2 times our x. Our x is -1, so we say -1 plus c. So this will be when it crosses the equal sign, it becomes 6 plus, it will become -1/2. So let's simplify that. 6 minus -1/2 is equals to c. So we simplify this, there will be 12 minus 1, which is c is equal to 11/2. So meaning that the equation of this red line will just be y is equal to our m, which is our gradient, is -0.5 times x plus c, which is plus 11/2. So this will be the gradient of the equation BD. So BD. The coordinates of B. The coordinates of B, so try to solve this one. You just solve this equation and that equation simultaneously, and you find the coordinates of B, so which is similar to what we did in the previous example. So solve this equation simultaneously with this one, and you show me what you get. Then the coordinates of C, you use the midpoint equation. Okay, so midpoint just says if you're looking for the point in the middle here, which is B, the B is the midpoint here. What you can do is you simply just say x comma y is equal to x1 plus x2 divided by 2. That will give you the midpoint. Then comma x y1 plus y2 over 2, that will give you the other point. So now in this case it's the reverse. So instead of finding the midpoint here, you just need to find this length from here to here. Okay, after you find this length, remember Nish, you've already found the coordinates of B. So the length there, you just add to the coordinates of B there, and it will give you the points of C there. So I'll be waiting to see what you can do for question B. Then I think this is it for tonight. Have a great evening.